Let's look at the answers to quiz 1X. Question 1A, find the limit as x goes to -1 from the left. So I'm going to trace along the graph here, and from the left, you see as we get close to x equals -1, we are approaching the y value of +1. So that limit is +1. Part B is the limit as x goes to -1 from the right side, and there we are approaching 1 as well. Part C, find the two-sided limit as x goes to -1. Well, since both one-sided limits are the same, the two-sided limit exists and is equal to that value. Part D, find the function value at x equals -1. Well, we have a hole up here where the graphs sort of ran into each other, but we have this solid dot down here at the bottom, and so that's the function value. And so that is -2. Remember that function values are denoted by solid dots, and holes are values that are undefined. Part E, is f continuous at x equals -1? The answer is no. The explanation is because f of -1 is not equal to the limit as x goes to -1 of the function. Question 2. Suppose that the limit as x goes to 5 from the right is equal to 4, and the limit as x goes to 5 from the left is equal to -4. What can you say about the limit as x goes to 5, the two-sided limit from both sides? Well, since the one-sided limits are different, one's +4, the other's -4, this limit does not exist. Part B, what can you say about the value of f of 5? Well, the question only gives us information about the limit. It doesn't tell us anything about the function values. You could have the function values equal to one of those limits, the other limit, or just some other random number like in the graph above. So we know nothing about this. Question 3. Find the limit if it exists. So first, notice that if you try to evaluate when x goes to 3, you get a 0 in the denominator. That tells us we need to factor. So the limit as x goes to 3. The numerator factors by the difference of two squares. So it's x minus 3 times x plus 3. The denominator factors by x minus 3 and x minus 8. Notice that we have terms that are x minus 3, and those are the two factors that were causing zeros in the numerator and the denominator. Since they are canceled now, we now have the limit as x goes to 3 of x plus 3 and x minus 8. Since there's no more zeros in the denominator when x goes to 3, we can evaluate. We substitute in x equals 3, so we get 3 plus 3 over 3 minus 8, which is 6 over -5, and I'll write the negative out front. The answer is -6/5. And lastly, find the intervals where the function g of x is equal to 6x minus 8 over x cubed minus 5x squared is continuous. G is a rational function. Rational functions are continuous everywhere that the denominator is not equal to 0. So we take the denominator, set it equal to 0, factor, and solve. So we can factor out x squared, leaving me with x minus 5 equals 0. Set both of these factors equal to 0. That gives me x equals 0 and x equals 5. On the number line, we have 0 and 5, and these are values that I need to jump over. Every place where there is shading now is an interval where this function is continuous. I see that we have 3 intervals. Those intervals are -infinity to 0, union 0 to 5, union 5 to infinity. Let's look at the answers for quiz 1Y. Here we have a graph, and part A says find the limit as x goes to 2 from the left. So I'm going to trace over the graph here, and as we get closer to x equals 2 from the left, we see that the y value goes to 1. Part B, find the limit as x goes to 2 from the right. I'm going to trace from the right side as x goes to 2 from the right side. We see that we get down to -4. Part C, find the limit as x goes to 2, the full two-sided limit. Well, since the two one-sided limits are not the same, the full limit does not exist. Next, find the value of f of 2. That's where the function is defined. You look for the solid dot where the function would be defined, and that is at 1. And part E, is f continuous at x equals 2? The answer is no, and that's because the limit as x goes to 2 of f of x does not exist. Question 2. Suppose x goes to 5, the limit as x goes to 5 of f of x is equal to 7, and the function value f of 5 is equal to 9. What can you say about the limit as x goes to 5 from the right, and what can you say about the limit as x goes to 5 from the left? Well, since you have that the limit exists and is equal to 7, you know that both one-sided limits have to have that same value as well. If either of the one-sided limits was different than the other, then the limit would not exist. Notice that the fact that f of 5 is equal to 9 does not play a part in this question. Simply knowing that the function value at 5 is 9 is irrelevant. In fact, the graph may look something like this. X is going to 5, the limit is going to 7, it may look something like that, and the function value itself is 9. So there's a solid dot at 5, 9, but there's certainly an open circle, a hole, at 5, 7. Let's look at problem 3. Find the limit if it exists. So if you were to plug in x equals 7, this one may actually work. Let's see. Seven squared plus 3 times 7 minus 28. That would be 0 over 49 plus 21 minus 28. The bottom is not going to be 0, it's going to be 42. So 0 divided by 42 is 42. So this one you did not need to factor and cancel. It was going to work anyway. Problem 4, find the intervals where the function g of x is equal to the square root of 15 minus 4x is continuous. So recall from our notes that a square root function is continuous everywhere that the inside function is greater than or equal to 0. So we'll set 15 minus 4x greater than or equal to 0 and solve for x. So move the 15 to the right side. We now have minus 4x is greater than or equal to negative 15. Divide both sides by negative 4. And recall from algebra that when you divide an inequality by a negative, you need to switch the inequality. So the function is continuous on negative infinity to 15 over 4, closed at 15 over 4.